Hey, welcome to the Peter Show. What a lame name. I mean, this is just lame. So, this is my second try because I recorded something like a 30 minutes video with creeping sound, like creeping. Is that an English word at all? Doesn't matter. So, this is about the history of cloud with Peter. Like, this is Peter. And Peter is not fun. Peter is a very boring guy. So, you're gonna have no fun here. We're gonna talk about serious stuff, like how the cloud or the public cloud was born. As I remember, I mean, this is very important warning here, as Peter remember. Because Peter doesn't remember too well. So, let's talk about the whole cloud computing stuff and how this started, right? Let me just tell you about my young ages when I got my first personal computer. It was something like this, like a huge machine with a huge drive here, and it had some even bigger floppy drives here. And this beauty was called IBM XT. Yes, that's right. I mean, I'm so young, I'm a youngster, that I didn't have any Commodore or other stuff. I started an IBM XT. Just for the records, all my friends were like 286 and stuff like that in the time, so I wasn't from a rich family or anything like that. So this thing, this huge drive, it's like an MFM drive. It was crazy stuff. It was really crazy stuff. You wouldn't really figure out the capacity of this disk was like 20 megabyte. I mean, no kidding there. And these discs, I think they were like 360 kilobytes or something like that. I'm pretty sure that this thing had like 640 kilobyte of memory. The the famous words. There's no slash here. That doesn't matter. And this was crazy. There was like a small button here to call turbo. With turbo mode, this thing was able to go 12 megahertz, right? Crazy stuff. I don't even mention this CGA monitor. I mean, you wanna maybe check that. It had like 4 color, I think, 4 amazing colors. And okay, so we started from here. You had a PC, and it was much better than TIE fighters, and we were like super happy, and stuff like that. And the next step, and the next crazy step, was for us, I don't draw a whole full-blown PC again. It's the connecting two PCs. I mean, when all my friends started to have PCs, we were like, oh, it would be great to play together somehow. And the first connections, at least we made, were through serial port. And this is like serial port. You can imagine it wasn't fast or anything, and it was something we call nowadays point to point, right? It was connecting 2 computers and not more. This was not like fully networking yet. Later on, we managed to get our dirty hands with my friends on some coax network cards, which were going to Isolocal buses on the motherboard, which was crazy because we were able to connect more than one friend with a coax cable. And there was magical stuff called here a T connector, right? So it was like you had to have the pieces like this, and at the end you had to have a closing end, so there was like a resistor at the end. And it was like amazing for us already. We were able to send packages between the machines and so on and so on. And why I started to talk about this, right? With this YouTube beauty came something called MS-DOS. It was an amazing operating system back there, and it came something called QBasic. That was the first language I ever met. I was able to write a program to add 2 numbers. I mean, that was the word for me back then. And that's, the rest is history. So maybe later you will be happy to hear these details. And so, this is how it started. And then something really important comes a couple of years later. So there are some years here, right? Years. When finally it's reached Peter. And that crazy stuff was like to run a virtual machine, right? I was already in the high school. I can remember we were talking with some friends. Oh man, I can run a virtual machine on my PC. So how these things works? You have a PC, you have a hardware. On the hardware, you have some operating system, and on the operating system, you can run some processes. And that process this one particular program was able to simulate slash emulate, I never know which one is which, a whole PC. So they were like, okay, from this software, let's make a virtual machine. So everything below is the virtual machine, right? And this virtual machine was with a emulated hardware. And on top of that one, there was again an operating system where we were able to run again the processes. As you can see from my figure, your computer is full with it. So back in time, this was a really heavy task. But this one was bringing some really interesting things, because this layer was basically separating now the machine from the whole thing. So you were not anymore worried about the drivers from the operating system to running your hardware, because that hardware was just emulated, and this emulation was able, we were able to do this on many other PCs. So that was great. And this came with some features, right? We were able to take snapshots of the whole machine. So we talk about the whole disk and memory and everything. This really opened lots of new possibilities in hunting bugs and so on, and moving these things around, right? The great thing was here that I was able to start a virtual machine, install an operating system in it, configure it, add my application on top, and so on, and then take a snapshot. And that snapshot was like, a turn back point in time. So after that, whatever I did, I was able to always restore the snapshot. So we invented time machine, which was really important for us. And then there was my friend, right? Okay, I had no friends, but if I would have money, that would be like, it's Peter 2, my imaginary friend. Shut up. So Peter 2, I can just give him the machine snapshot and he can restore the same thing. So that was pretty amazing back in time, and how the evolution of this thing went on, right? But then many places started to use virtualization in their data center. So let's just draw a data center. This is a rack here, and the racks, you have different machines. Let's not call them PCs anymore, let's call them servers, because these are not really personal computers anymore. And that was great, but there was still a couple of issues here. One thing is that you had to somehow maintain that where do you run what virtual machine, and these things needs networking, right? So let's just put here networking. Oh man, I cannot write this way. Net, perfect. And this is all good and nice, but it came with a cost, because you had to buy all of those things, right? So and that's just not cheap. But let's not jump that far, right? So let's just talk about Linux now. So in Linux, you have this great stuff. Let's just draw it like this way now. So you had the hardware, and on the top of the hardware, you're running some kernel. And I'm warning you, this is really high level, and my knowledge is not deep in every one of these areas, so never mind. And there is a user space, and there is a so-called KVM, so the kernel virtual machine, which is basically like this. Is that what it stands for? I'm not even sure. That's what it stands for now, but never mind. And then on the top of this KVM, a little bit still in the user space, or let's just call this the rest of the user space, you can put additional things, like there is a CLI for the libvirt, or sorry, I was running a little bit ahead. So here we have a so-called libvirt, right, which is an additional layer already, and it can handle lots of things for you. And on the top of libvirt, there were some CLIs for the users, and there were some, you can use the virt manager, for example. But this is all nice and happy, but we are still inside of one PC. Although libvirt is kinda able to cooperate with other PCs on your network and do some tricks like moving virtual machines between two host machine, as we call them, but it's still not perfect. And this is where OpenStack was doing something great. See, OpenStack. This is something definitely to search for if you have no idea what is this. And what happened here, without drawing the full picture now, they added an additional layer here, OpenStack, which was solving a lot of issues and making it possible to run your virtual machines through many nodes. But before we go there, let's just play with this idea now for a little bit, that what do you need to build a cloud provider? I mean, just, on high level, logical level, you will definitely need some machines where you have CPU power. Let's call these, what should we call them? Okay, I draw one more so I have some time to come up with the name. Yeah, let's call them compute nodes, right? These are the ones doing the heavy lifting when it comes to CPU. Yep, node, just like this. And that's nice. So now we can start up virtual machines, right? On this little thing we can start a VM, but to start a VM we need an image. So we will definitely need something which can hold and handle images for our virtual machines, right? If I recall right, this one is called Glacier in OpenStack lingo, but never mind. So we have a service which can provide the images for virtual machines for those nodes. And this is great. Now we can start virtual machines, right? Except we will need something more. I mean, now it's nice, you can start up a virtual machine, it will have an image, but by definition, or how this thing works here, right? Most of those images are read-only, or even if you can write them, when you shut down or delete the virtual machine, they're gone. So many of the applications screaming for something called persistent storage, right? So we wanted to separate the storage things, and we just make this persistent storage. We will definitely not go into there because storage is usually, what people are getting specialized in, and there are people only working on this. But for the story, right, you just want to connect these virtual machines somehow to some persistent storage. So whatever they do, they can save it for later, even if you stop the virtual machine, and so on and so on. Don't even mention that, the images are usually stored in a persistent storage, so this can have some unholy connections to each other and so on. Let's really not go deep there, that how you would solve this now in a data center and so on. This is just about the high level logic. Now there is something here we haven't mentioned yet, right? There is no networking on this picture, so you can have all of these components running in the same PC. It doesn't make too much sense, but you could take it. So we'll definitely want to have something which is handling the networking. That's again something we won't go deep now, because networking is a really wide story. So there's a networking, let's call it node, but you can call it whatever. And then these are the basic building blocks to have a cloud provider, right? So now you can at least start up virtual machines, aka instances, and those things can communicate with the network and can save stuff to the persistent storage, stuff like that. These are the really basic services, right? You need, or you can have more services to make it more meaningful, but that's something we can learn about later. Now with these basic services, you have to do stuff, and this is how basically the private cloud was born. It's kind of funny for me, that between the private cloud appearing and companies starting to investing money and researches into this, how to do these things, there is not a big jump to the public clouds. Now, so what's the idea behind the public cloud? Let me just go back here for a little while to our big data center, right? What's the main problem or challenge for you when you decide at home that, hey, I want to do things with cloud, so I build a cloud provider? Now, this thing is cost you money. And of course, all of those are costing you money, right? So there's no question buying servers is expensive. And the networking costs you money, lots of money. And then we just mentioned storage, right? But let's just put here storage. A proper storage costs you like lots of money again. And this whole thing is powered by electricity, right? So this goes to the electricity, which again costs you money. And then don't even mention, when you have a complicated system like this, you need at least one Peter, responsible for this and that. You need like 2 Peters for the networking for sure, and you need lots of Peters for storage, because I have no idea about storage things nowadays. But the point is there, right? You need stuff to maintain these things. You have to have monitoring to run it 24/7. You have to have lots of things. And which is kind of, if you're counting these dollar signs, there is a huge upfront investment, and that's something we don't like because we don't have money. Plus there is a monthly fee. I mean, let's imagine that you decide that you don't want to play with this thing and you just shut down the whole thing, right? You say that, okay, I actually done the whole thing, this doesn't cost me any money. This money you already wasted here. These guys, even if you fire them, it's gonna cost you a lots of money. And then there is still one thing you should consider is storage. I mean, storing these physical equipments, this is taking space. I mean, you need a lot of space for an equipment like this, and it's not cheap either. So the idea with the public cloud was, so hey, let's have these nice people. I'm just kidding, it's all about the money. They were like, hey, let's build this one, it's cost a lot of money, and rent it out, right? The idea is to renting out expensive stuff. It's an old school thing. I mean, there is nothing new there. If you cannot afford the house, you can rent one. If you cannot afford a car, you can lease one. If you cannot afford the cloud, you can borrow one or renting one. And this is what's happening. But why is it good for you? And why is it good for me? And why is it good to anyone, right? Of course, the ones who are renting it out, they're making money. But for me, I don't have to make any upfront investment, and I only have to pay a monthly fee, and that monthly fee will be much lower, right? It's a very small dollar sign, and it's only depending on my usage, right? If I would just have really a basic case to run on this thing, I would have to pay like 1, 2, 3, 5, whatever, salaries, electricity, everything. So to starting with the public cloud is very cheap, and that's good for us. The thing is that even the learning curve, right, the amount of knowledge you have to know, it's very limited, because these clever people were getting this whole thing and they, put it in a nice package. let's just draw you something, right? So now I can use the magic color. Public cloud was born. And the funny thing with the public cloud, or the amazing thing, that these people were like, let's make it granny easy, right? So let's make it so that anybody can use it. And they were putting a web UI in front of it. So now you can go to your browser and you can just clicking around and making networks and making storages and start instances and play around it. They were like, okay, of course, for the heavy-minded ones who wants to have advanced features and so on, we will have a CLI. And this is still not end of the benefits, right? Because there is one huge benefit of this one comparing to this one. In this one, what you had, most of these servers had some server management. It was like an extra hardware, so you can turn these servers on and off remotely, or you were able to buy power rails, or power distribution units they call them, so PDUs. I must draw one. I cannot, PDU, which had network on it, so you were able to remotely log in and restart this server and that server and that server. And when the server network connection was done, you maybe wanted to have a serial attachment, so you can log into the serial cable console. So lots of extra hardware and stuff. Again, this costs you money. I mean, I can tell you, just a single PDU costs you a hell lot of money. And you don't have those things with this. Plus, don't even mention that when you build up these things, likely you won't be able to buy all of these equipments from the same vendor. So if you want to do something programmatical, right? Because what's the ultimate target here is to write a program which can build you an infrastructure. I mean, if you have this one, your program could be able to write a virtual infrastructure, right? But here you would have one API and you would have another API. It's an application programming interface, if you're wondering. You could have like several APIs here, and you would have another API here. So your program would be like crazy hell complicated. All of these things were built into the public cloud. So most of them is coming with an application programming interface, usually a REST API. REST, right? Which means that right now Peter here is able to write some super simple program handling the API, which will build me any kind of infrastructure in the public cloud and make it accessible for me. And this is amazing, and this is something you should consider when you start to build up new things. Now, this would be the introduction, and you know, if you get interested in the topic, I have much more to tell, but I want to see how this goes out, and if you guys are interested in this kind of style of tutorials, and you know, I'm just wondering if you like this, and if this is something you think is necessary and useful and so on. So what I would like to ask from you, if you like it, just like it. If you're interested in following this, then subscribe. And first of all, which is more interesting for me, it's share. You know, just go tell to your friend that you have seen a crazy cool video explaining to you what is public cloud and how it works. Hey, thanks a lot for listening. Bye.